Alright, this question here says the question here says if 7 workers can build 7 cars in 7 days, 7 workers can build 7 cars in 7 days. Then how many days would it take 5 workers to build 5 cars? So you should expect this kind of questions because I think it comes out almost every single interval whenever they take the GRE exams. Questions like this they come up. So I'm going to explain to you a very efficient way of solving this problem. Now from the first statement here, from statement 1, it says if 7 workers can build 7 cars in 7 days. So let me call this statement 1. So statement 1 says 7 workers can build 7 cars. So they build 7 cars, and those 7 workers they build the 7 cars in 7 days. So what I'm going to do is I'm going to represent my workers with W. So we'll call the cars, we'll represent with C, and then the number of days we'll represent it with D. Now this is what the first statement says. Now but for the second statement it says how many days would it take 5 workers to build 5 cars? So for the second statement we have 5 workers. So 5 workers they build 5 cars. Now we are told to find how many days would it take to build 5 cars by 5 workers. Now to do this, I need to let you know that this kind of question is an example of a joint variation question. A joint variation is a joint variation question. So how do you go about solving problems of this nature? Now listen, from the very first statement you need to establish a relationship between the variables which I've listed above, W, C and D. Now the first variable we have here is workers. So I need to know what is the relationship between the workers and the cars. Now the higher the number of workers, the higher the number of cars that will be produced, and then the lower the number of workers, the lower the number of cars that will be produced. So that implies that there is a direct relationship between the number of workers and then the number of cars. So that means W is direct proportional to C. But then what is the relationship between W and D? Now the higher the number of workers, the lower the number of days it will take to complete building a car, and then the lower the number of workers, the longer it will take them to build a car. So that means there is an inverse relationship between W and D. So you'd say W is directly proportional to C but inversely proportional to D. Now assuming there was a direct relationship between W and C and W and D, we would have written this as W to be directly proportional to C and D. It should have been written like this, but because there is a direct relationship between W and C, an inverse relationship is going to be denoted by the reciprocal of D. So this is it here. I've established a relationship here. Now the next thing is I need to begin to solve. So the first thing is, if you have established a relationship properly, then every other thing is a breeze. So the next step is, I can't solve this because this is a proportionality sign, so I need to change this proportionality sign to an equality sign. And then to do that, so anytime you change the proportionality sign to an equality sign, you always attach the constant of proportionality to this place here. So this is the equivalent of what you have there. So this is W equals KC all over D. Now from the first statement here I can find K, why, or how. So from here it says when W is 7, C is 7 and D is 7. So it says when W is 7, so using this one here, so my W here is 7, so you have 7 equals, so we want to find K, this is what we want to find, times, so our C, this is our C here, our C is 7, divided by our D is 7. So when you cross multiply, so what you're going to have is, this is going to be 7 times 7, which is going to be 49, equals K times 7 is going to be K. So you divide both sides by 7. So we can find K. So 7 and 49 is going to give you 7. So you have k to be equal to 7. So in other words, I've been able to find my k to be 7. So this k here is 7, so I can now rewrite my equation as w equals, so let me write that here. You have w equals, so my k is 7, so it's going to be 7c all over d. So in other words, this equation here actually models the behavior between the workers, the cars, and the days. So now let's go back to question 2. Now question 2 says, now when the number of workers is 5 and when your c is 5, then what is going to be your d? That is what we want to do now. So since we are told w, so you recall this is our w, so our w is 5 equals, so this is 7 times c, so c is the number of cars, that is 5, divided by d. So we want to find d. So again, we'll cross multiply. So when you cross multiply, all you have here is going to be 5d equals 7 times 5. So to find d, I need to divide both sides by 5. So you divide by 5, you divide by 5. So when you divide by 5, so this goes off, so you have your d to be equal to 7. So that means for this statement here, the number of days has to be 7 to satisfy the model that we have formed from the first statement. So our answer is 7. So and that tells us that the solution here is 7, and that completes the problem. Thanks for watching.